Hi physics fam, we are going to do some practice with the kinematic equations. We have a problem here where we have a runner accelerating to 4.2 meters per second squared for 10 seconds before winning the race. We are looking to figure out how far they ran during this time. So the first thing that I usually suggest people do when they're first trying out practice problems is identifying all of the information. So we have a runner accelerating at 4.2 meters per second squared for 10 seconds, and they win the race. We're looking to answer how far they have run. So those are the pieces of information that immediately stand out to me. The next thing that we're going to want to do is list all of the variables that we have. So now that we've identified those pieces, we're going to assign variables to them. So we have acceleration, we have time, and we're looking for how far. So we have delta x here. So let's go ahead and list those over here. We have acceleration is 4.2 meters per second squared. We have time is 10 seconds. And then we are trying to solve for how far we've traveled. So it doesn't really matter where the runner has started. We can say that the starting position is 0. So the how far is going to tell us our final position, as well as our displacement. So the other thing that we have from this particular problem that isn't explicitly stated is that this is a race. So at the beginning of a race, all runners are going to be at rest, right? So we also know that our initial velocity is 0 meters per second. So it's really important to make sure that you're thinking through the context of the problem, because they're not always going to give you every single piece of information. You'll also have to think about the context and apply it to the scenario. So we can now look at our formula sheet and identify which equation that we're going to use. At first, my suggestion is always to look at the formula sheet and start at the very top and then go through and figure out if you're able to use the equations. So the first two on our formula sheet we said we can't use because there is acceleration involved, so we just throw them out entirely. The next one needs displacement, which is what we're solving for. It needs initial velocity, got it. We need time, got that as well. And then we also need acceleration. So it looks like that equation is going to be what we're using. So let's write it out. We have final position equals initial position plus initial velocity times time plus 1/2 at squared. So from here we can plug in all of our information. We said that our displacement, it didn't actually matter what our initial position is, so let's just go ahead and call that 0, and we're going to solve for our final position. So we can get rid of this as 0. We also know our initial velocity is 0, so this entire term goes away, right? Because anything multiplied by 0 is going to be 0. So now we're just left with 1/2 the acceleration of 4.2 meters per second squared, and then the time interval of 10 seconds, and we can't forget to square that. So here we have 1/2 times 4.2 times 10 squared, and that gives us a final position of 210 meters. So we're going to box our answer, and the runner has run 210 meters. I hope this was helpful.